In this section, we'll consider Python classes. Classes are a key concept in the object-oriented programming. Classes provide a means of building data and functionality together. A class is a user-defined template or prototype from which real-world objects can be created. The major merit of using classes is on the sharing mechanism between functions and objects. The functions in a class are called methods. The initialization and the sharing boundaries must be declared clearly and conveniently so that a class tells us and what data an object should have, what are the initial default values of the data, and what methods are associated with the object to take actions. In fact, this bullet is a kind of implementation requirement. So in that way, you have to implement a class. An object is an instance of a class, and creating an object from a class is called instantiation. In this section, we would build a simple class as Dr. Su did in his book. Dr. Su is a math professor at Southern Methodist University, Dallas, Texas. In this section, we will learn how to initiate and how to define and how to use classes. Okay, let's initiate a class. The class name, polynomial, is defined, and here this is a docstring. Now there are two functions. Each one is called a method. This init method is a special method for initialization. Once by using this class, once an object is made, as in this line, so polynomial with this data, and P2 is an object produced by this polynomial class, then this one is initialized. And so that init is called the init constructor and automatically initialized. Now it requires two, right? You can see two arguments, but for self, you don't have to give any data. But for this one, you have to provide the values. So it'll take this input, and by using that, now self quef is made. Now, once it is using self prefix, then that will be shared to every other method, and also it can be accessed from objects in this way. Object name dot quef, then that one is accessed. That is rule. Now we have another method, self, which means that it is not requiring any input. But now, because of self-quef, it is available here because it's shared, and we measure the length of the array, and -1, that is degree of the polynomial. Right now we have 3 components. Is for polynomial, for example, x squared plus 2x plus 3. So degree is 2 with the 3 coefficients. right? So there is very simple class. Okay, I explained this all of this one. Okay. Okay, now we try to define the polynomial class here. Now, for this one, we defined this one outside a method. So it's one line. The variable is used in this case. That one is called a class attribute, but that one is belong to the polynomial. And now it should be accessed by using that one. So the polynomial dot count, and outside of the class, so in object, it must be called in this way, and then it is shared for every object. Now that one, for example, this one is accessed by objects, but for each object, the coefficients can be different. And by using different input, you may try to make this array, but this one is global parameter in a sense, so that it is shared by every object. So it is a kind of a global parameter. Now for this init, there's no other input except self, but for each method, you have to have a self everywhere. Self, so it is not requiring any input, but the coef will be initialized with number one entry. Now that one, count is used everywhere, and along with the polynomial prefix, the class name. So here, once it is initialized, then this count is added by 1. This count is counting number of objects created by this polynomial. So that once it is called, then in initialization, now the count is added by 1. Here we now define here that function, that is deletion of objects. By using this one, you can delete. In fact, the object can be deleted by using the built-in function del. Now, if you define this one, then this will be performed. Without this definition, of course, you can delete objects by using del. But with this one, now the count will have value 1 less than earlier one. And that is the definition here. Now here degree, okay, that is the same as earlier. Now we can here define evaluate. Now for given x has many points. So the given array, we try to evaluate the function value, and then here eval, the array will contain the values corresponding function values for x values. So you can add over there, so that here now the degree and also and self-coef are available from, it is made and considered in the method, but it is shared inside the class. Of course, this accessed by using the object name dot the second part, the behind part of self. Okay, by using object name dot degree, you can access the method. Okay, let's see here the calling. And so in refinement, you can add such global variable, and also you can do a different initialization, and also you can add some deletion operations, and also you may add some other method. This way is newly added. In this way, you can refine, and you can use that those method in the class. Now here, poly1, because initialization doesn't require input, just we open an object, create an object without any input. Then it's once you open it, then default coefficients must be 1 here, only one entry here, like that. It is initialized there. So we can print out to see if, okay, let's see here, that is now initialized coefficient array. And after assigning, so we can access by using object name and this coef, and we assign it. And after assignment, we can see it. The result is this one. Now we can check the degree, and after reset the coefficients, we can see also degree. That is exactly the information here, the implementation. And after reset, we see the coefficients, and 3 will come out, and also degree is 2. Now we create another object, and along with object and name and coef, we assign this one. Then this one and that one are different because along with a different object, they must be different. Now after reset, we already saw the output. There are 5 the entries, and degree must be 4. Now at this moment it is called and printed out. It must be 4. Let's see if it is really 4. Here you get over there 4. Now we are checking number of created polynomials. Okay. For that, now here we try to print out the created polynomials. Here already we constructed 2, so the first answer must be 2. And we delete polynomial 1, the object. Okay. Without this one, again I say, without this one you can delete. But because of that one, in corresponding to the delete command and with that definition, the polynomial count will be reduced by 1. Okay. So that this is reduced by 1, and after that we can print out the polynomial count. And here for polynomial 2, we try to evaluate at these 4 points, and so that we print out. Okay, let's see here the result. Before deletion, we have 2 polynomials created, and after deletion, it is reduced by 2. And at this point, the function values are here. Okay. Okay. So basically, in refinement, you can declare global variables, and so you can do some other initialization, and also you can add some deletion of objects, and here other methods can be added. In this way, you can define your initialized class to become more convenient and more useful. Now we consider the inheritance. If we want to write a class that is just a special version of earlier made another class, then we don't need to write the class from the scratch. Just we can use it, and now we can specialize, so that we call the specialized class a child class and other general class a parent class. The child class can inherit all the attributes and methods from the parent class, but it can also define its own special attributes and methods, or even it can override method of the parent class, just redefine some methods. Classes can import functions implemented earlier to define methods. Let's see this. Okay. Okay. Now here, in this file, we try to import user implemented the function inside util poly, and every function inside the file is imported. Now we define here polynomial as earlier, and this is the initial class we treated very early. Now from this polynomial, we try to define a child class that's quadratic, and we have to put the parent class name. That indicates that already the Python knows that this is a class. And if you write in this way, then that means quadratic is a child class of polynomial. Okay. Now here, and once this quadratic class is used, then once object is made, then it must be initialized. And here we have self and coefficients by using this input. And here we try to initialize by using the parent initialization method. So super key, that one, is use exactly the same initialization function from the parent class, so that this initialization will be used. But in this one, new one, you may add one more line here, so that another new variable is created, self, and so it can be shared to other method. Self power decrease equals 1, so that this variable will be shared for every method and every object created by the quadratic class. Okay. So you can adjust, but that line is using the parent, the initialization, and additionally it is added. Now here the roots. Okay, you can implement here long program, but you may try to use for quadratic polynomial root function can be used by using coefficients, and here power decrease, so that the coefficients is collected along with the assumption that the power decreases. Now that means here three values, okay, that is A, B, C are there, then that means here decrease is ax squared plus bx plus c. Okay. Okay. Along with that convention, here the root will be made. And for degree, now that is override the parent one. The parent class is defined in this way, but the quadratic always degrees 2, so that without any further checking, simply return 2 is okay for quadratic polynomial. So this one overrides the parent degree function, degree method. Okay, so in this way, you can define child the class. Okay, let's see here. The util poly.py include roots for quadratic, the quotient and power decrease, and that is coefficients are given in this way. So the assumption is now power decrease is 1, but power decrease is 0. Once it is 0, that means power is increasing, which means that ABC is used to in this way: A plus BX plus CX squared. But later on here, the computation is done along with the assumption that the power decreases, so that once you change A and C swap, then now you can use this portion without any further the change, so that here just swap and use it when power decreases not 1, right? That is a function. It is implemented so that it can be used independently at the class. But if you implement this portion inside here, this portion, then you may try to use along with the self prefix and also this one, so that this portion is not useful outside the class, so that you may try to implement a function and independent of the class variables and use it to get the solution. You can do it. Then you can enhance the usability of functions. Okay. And here we import the everything from classes, and by using the quadratic class, we open one object, and so for object we return, compute the roots, and here we just change the value. Power increases 0 means that decrease 0 means that this one is collected for the polynomial, this one. So it's increasing means this one is a 3 minus, okay, no, not 3, 2. So 2 minus 3x plus x squared. But when power decreases 1, default value is 1. So that is for 2x squared minus 3x plus 1. For this one, the roots are this one, and for this, the roots are here. Okay? Okay. Here we have final remarks on Python implementation. A proper modularization must precede implementation as for other programming languages. Modularization means that for all operations, you have to separate the groups of operations into to make a function. So you have to modularize whole operations so that you produce a number of functions. Each function includes some portion of operations. So you have to make such modularization properly. Of course, for every programming language, you have to do it and before implementation. Classes are used quite frequently, but you don't have to use classes for small projects. And try to use classes smartly. Quite often, they add unnecessary complications, and their methods are hardly applicable directly for other objects. So you may implement standalone functions to import. In this case, we implemented that function standalone. It can be used in other projects. But if you use only this portion in the class, then it's not easy to use it directly for other projects. And this strategy enhances reusability of functions. For example, the function _quad defined in util poly.py can be used directly for other projects. Afterwards, you'll get your own utility functions. Using them, you can complete various programming tasks quite effectively. So try to use classes smartly. Then you can be a good programmer. Okay, thank you.